This question is also related to energy, work energy and power. A soft rubber ball of mass 0.15 is dropped in a vacuum. So if it's in a vacuum, there's no air resistance. The force is not opposing, any force is opposing its motion. So it will not lose energy. From a height of 2 meters, it hits the hard surface and the ball bounces. State the main energy change that takes place when the ball is falling. So what is the energy change when the ball is initially falling?
Potential to kinetic.
Potential to kinetic, when it is falling. And you have to mention energy change, so you have to mention from one to another. So here it will be potential because it is at certain height, and to kinetic I'm writing in short KE. The ball hits the surface and changes the shape. What is originally the ball was dropped, so moving down, so potential was changing into kinetic. But then the ball hits the surface and it changes its shape. So kinetic to elastic strain. And you have to mention energy change. You cannot mention like which form is there, like which form or what is the change in energy. So you should mention kinetic to elastic strain. There is a friction with the surface, but the thing is there is no air resistance opposing the motion. And sound energy, why you are not mentioning like the sound? You can mention sound, but why the sound may not give you a mark here? Because they did not specify that when it hits the surface it produces sound. It will produce sound, but maybe not in an audible range. So the main distribution of the mark is kinetic to strain or elastic strain energy. The ball regains the shape and rises from the surface. The ball bounces back and it regains its shape. So regain the shape, like shape, its elastic strain energy changes to kinetic and then potential. Or you can mention potential to kinetic, but mainly it is elastic strain. To kinetic. Or you can mention because it rises, so potential as well. As the height increases, it might change to, or it will change to potential as well. Now in this question, the calculation part now. Calculate the speed at which the ball hits the surface. So how I can find the speed at which the ball hits the surface? So this ball is at certain height above the ground. So it is at a height of 2 meters. And the mass is 0.15. So which form of energy this ball will have when it is at certain height? Which form of energy this ball will have when it is at certain height, at a height of 2 meters above the ground?
Potential.
Potential or gravitational potential. So it's having a potential energy. How much is the potential energy? How you can find? You can use the formula mgh. I need a speed, but directly I cannot find the speed because I don't have the kinetic energy. Because to know the speed, I should have a kinetic energy so that I can find the speed. So which form of energy it will have? Potential. What is the potential energy at this point or height? That's equal to 0.15 multiplied by 10, which make 1.5 multiplied by 2. So when I multiply all of them, how much is the potential energy? That's equal to 3 joules of potential energy. As it is coming down, the potential energy changes to kinetic. If there is no loss, if there is no loss of energy, energy does not loss because there is no air resistance, then how much is the kinetic energy before hitting? So originally it was having potential. Just before hitting the ground, how much is the kinetic energy? Or what will be the kinetic energy? So the kinetic energy will be equal to 3 joules. So now first we get the potential energy, and using a potential energy we know the kinetic energy, and using a kinetic energy you can find the speed. Kinetic energy is half mv square. So you have the mass, you have the kinetic energy, you can find the speed. This is one way. There's also another way, and that's a very short method which will give you the answer directly. You don't have to do many calculation for this. So what happened, as you know, at the height it will have potential energy, and potential energy is given by mgh. Before hitting the ground, or just before hitting the ground, it will have kinetic energy, that is half mv square. And if there is no loss of energy, if the energy is not lost, so I can say the potential energy is equals to kinetic energy. Potential energy is mgh, and kinetic energy is half mv square, or 0.5 mv square. So m is common, m will cancel with m. So what I'm left with gh is equals to 0.5 mv square. This formula you can use if there is no loss of energy and the potential energy is equals to kinetic energy. So you have the gravity is 10. You drop the object to a height, from a height of the height was given 2 meters. So you drop this from a height of 2 meter. This will be 0.5 and v square. 0.5 is multiplied, other side it will divide. So it will be 20 divided by 0.5, which is equals to 40. So 40 is equals to v square, or v square is equals to 40. Just take a square root. So v is equals to square root of 40. What's the answer? 6.32. 6.32. So that's equal to 6.32. So keep in mind, whenever in a question the potential energy changes into kinetic, or kinetic changes to potential without any loss, if there is no loss, then you can simply use this formula that gh is equals to 0.5 v square. So what it shows you don't have to bother about the mass. Even if the mass is not given in the question, you can use this formula and get the answer. But this is only valid when there is no loss of energy, or all of the potential energy changes to kinetic energy. Is it clear? Any doubt in this?
No, sir. Clear.
In the question, the object is dropped from certain height. When we drop the object from certain height, so which form of energy this object will have? So it is at certain height, it is at a height of 2 meters. That's potential energy. So mgh. When it just before hitting, so just before it hitting, it will have kinetic energy. So all of the potential energy will change into kinetic energy when it will hit the ground or just before hitting. So we can say the potential energy is equals to kinetic energy. Potential energy is mgh. Kinetic energy is half mv square. So m is common, m can cancel with m. So you're left with gh is equals to 0.5 v square. V is the speed at which so we have the gravity, which is 10. We know the height, h is there, 0.5 and v square. So we can find speed at which it hits the ground. After rebound, as a ball rebound, the ball rises to a height of 1.9 meter. Means we drop the ball from a height of 2 meters, but then as it bounces back, it hits the surface. It does not rises to a same height. It bounces back to a height of 1.9 meter. So why it does not rises to, so some of the energy lost to surrounding, and why some of the energy lost to surrounding in the form you can mention some energy lost to the surrounding in the form of heat. Is it clear? Then a similar question. A diver climbs some step on a fixed pattern platform above the surface of a water in a swimming pool. The mass of a diver is 65 and the platform is 8 meter above the water surface. Like example, if this is the surface of the water, the divers jump from a height of 8 meter above the water surface. And the mass of the diver is 65 kg. Increase in gravitational potential energy. So potential energy is mgh, mass multiplied by gravity multiplied by height. So mass multiplied by gravity multiplied by height. So mass is 65, gravity is 10, and the height of the platform above, it's 8 meter. So when you multiply them all, it will be 5,200 joules. Next, we need a speed, and we ignore the effect of air resistance. So if they say ignore the effect of air resistance, it means there is no force which opposes its motion or no energy lost. So if the potential energy before hitting is 5,200, how much is the kinetic energy before hitting the water surface? That will also be 5,200. Because if there is no air resistance, there is no energy loss. So potential energy is equals to kinetic energy. So when potential energy is equals to kinetic energy, potential energy is mgh and kinetic energy is half mv square. So again, m will cancel with m. So gh is equals to 0.5 v square. So g is the gravity, which is 10. H is the height from which you drop or the diver's jump, that's 8 meter, 0.5 and v square. 8 multiplied by 10, that's equal to 80. So 80 is equals to 0.5 v square. 0.5 is multiplied, other side it will divide. So 80 divided by 0.5 and then take a square root. You will get the speed at which the divers enter the water. That will be equal to 12.6 meter per second. So whenever there is no change, there is no loss of energy, the potential energy is equals to the potential energy is equals to kinetic energy if there is no loss, and we can find the speed. For example, another diver is there of mass 70 kilogram and he jumps also from the same height. If the mass of 65 kilogram diver, if the 65 kilogram diver jumps from the height 8 meter above, he hit the water with a speed of 12.6 meter per second. Another diver also with the same with a different mass, example 80 kilogram, with what speed he will hit the ground, he will hit the water surface if there is no air resistance? So it will be more than 12.6, less than 12.6, or equal to 12.6. If a diver of mass 65 kilogram jumps from the same platform as well as the diver of mass 80 kilogram, what will be the speed at which the 80 kilogram diver will hit the water surface if we ignore the air resistance? Air resistance is not present there.
It will be the same.
It will be the same. So it will be same. Why? Because there is no air resistance, there is no force which oppose their motion. So, and they will all have the same acceleration due to gravity, which is 10 meter per second square. And you can see here, when potential energy is equal to kinetic energy, the formula is GH is equals to 0.5 v square. So it does not depend on the mass of a substance. The speed at which the object hit depends on the height from which it is dropped. If we increase the height, the speed will increase. Is it clear?
Clear.
So I'll end the session now. Any question related to class today? Today I discussed the pressure exercises for 1 and 2 and energy questions. I'll share the weekly homework with you. And this is the end of block 1. Next class we'll start block 2.